Right. Good evening.
Good
Shall we
evening.
start the class? Okay. Good evening. So today we are starting chemical calculations, unit 3. So chemical calculation lesson is a highly important lesson because as I told you earlier as well, there are more than 25 marks will be allocated for calculated from the chemical calculations. Chemical calculations will not be asked directly, but these theories that we are discussing is uh, very vital for the calculations of the other lessons. For an example, inorganic calculations, uh, industrial calculations, and sometimes environmental calculations. Likewise, so those are very important chemical calculation lessons. So if there is a calculation, especially the physical chemistry, I forgot that one. So if there is a calculation in your scope that is coming from this scope, right? So this lesson is very vital. If there is a student who can't understand chemical calculations, that would be a big problem, right? So therefore, understanding this concept, understanding how to do a question, how to do a calculation accurately and fast and accurate way is very important, right? So therefore, you have to have thorough understanding on the concepts, and uh, some calculation skills are needed. That means the final answer, taking the final answer in a fast and an accurate manner, right? So you need a separate book for this one, Putta. So write the topic unit 3, chemical calculations. Right. So give me 1 second. Right. Sorry for that. So to start with chemical calculations, we need to know the concept of atomic mass unit. Atomic mass unit, right? Now let's try to understand what is atomic mass unit. We know there are many SI units. There are 7 or 8 SI units that we are used to measure the some parameters or quantities. Right? For an example, length is measured by meters, mass is measured by grams, and what else? Grams or kilograms? I can't remember. Right. So there are many SI units. Oh, I can't remember. This is coming from physics. So based on this unit, SI units, people are trying to measure the mass of an atom as well. But mass of an atom is very, very, very small value, and it is a complex value as well. For an example, mass of an electron is 9.109 into 10 to the power minus 31 grams. some people will understand this one, or some people will remember this one, some people will not remember this one. When it comes to mass of a total atom, that is also very difficult, right? So therefore, people wanted to have some kind of mechanism to measure the mass of an atom. So they tried to calculate the mass of an atom relative to some other ratio or some other defined item or defined ratio. Initially, people tried to measure this one compared to the mass of H11 atom mass, right? So how they have calculated this one is they take the mass of an atom and they divide it by mass of H11 atom. This was the initial atomic mass measurement. This mass of H11 atom is called as the atomic mass unit. Because it is used as the unit, right? So you take the mass of an atom, divide it by mass of H11 atom, and you will have some answer. Let's say for an example, this is 1. So this is called as 1 AMU, atomic mass unit 1. So likewise, they tried to measure this one, but this was a bit complex. The complex means mass of H11 atom is also very small. So therefore, the atomic mass units is also very small. So it makes some complexities. Then after some time, they use the atomic mass unit as 1/16 of oxygen 816 atom. They took the mass of an atom and divide it by 1/16 of mass of O816 atom. This is also used for some time, but this is also failed. Right? Failed means it was discontinued to use this constant. Then up to now, people have used 1/12 of mass of C16 atom as the atomic mass unit. Right? So they take mass of an atom, divide by any atom, divided by 1/12 of mass of C16 atom. So for an example, let's say now we know uh, helium is 2,4. This 4 comes from this calculation. They take the mass of helium atom, divide this by 1/12 mass of C612 atom. Right? So this is how they have measured mass of an atom. Because helium atom actual mass is like, for an example, let's say 6 point something blah 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 into 10 to the power minus 27 kilograms or something. Remembering that one is quite hard, but everyone knows mass of an helium atom is 4. So that is a relative mass, relative atomic mass. This is therefore called as, this 4 is called as relative atomic mass. It is relative to atomic mass unit. What is the atomic mass unit? This one is the atomic mass unit. Right? So This is the atomic mass unit used up to now. So initially they have used mass of H11 atom, then they have used mass of 1/16th of mass of O816 atom. Then after that they have used mass of C612 atom divided by 12, or 1/12th of mass of C612 atom. So this is how the concept of relative atomic mass, RAM concept, comes into the world, right? So if I take another example, if they say nitrogen 714, this 14 is the relative atomic mass. This is relative atomic mass, right? So 14 does not have any kind of units like grams or meters or candela or anything, or Newton or anything, but we call it as atomic mass units. 1/12 of carbon 612 atom is 1 AMU. AMU. So we say nitrogen is having 14 AMU, atomic mass units. So which means you take 1/12 of C612 atom, you calculate 12 of them, sorry, 14 of them, that would be equal to the mass of nitrogen. Simple mathematics, right? So this is how the concept of relative atomic mass comes into play, right? So let's try down about this or not. Any questions on this one? You can ask me if there are any questions.
No, sir.
Okay, good. So let's write down. Write the topic atomic mass unit. calculation of mass of an atom. Calculation of mass of an atom is complex. Is complex. Is complex when SI units are used. When SI units are used. Therefore, people wanted to use a relative method for the atomic mass calculation. Next bullet point. Initially, mass of H11 atom is used as the atomic mass unit. and mass of other atoms and mass of other atoms are measured relative to this unit. Relative to this unit. Therefore, measured mass was called as relative atomic mass. Relative atomic mass. Later, to the same point, later, this was discontinued. Later, this was discontinued due to the complexities. Due to the complexities. Right. You write down this one. Mention this H mass of H11 atom as the atomic mass unit. We are not doing any calculations for this one, but you need to know how people have defined the atomic mass unit. Okay. Okay. Next bullet point. Hope you have written down this one. Later, mass of 1/16 of O816 atom, mass of 1/16 of O816 atom was used as the atomic mass unit. But this was also discontinued. This was also discontinued. Next bullet point. with the time, IUPAC recommended to use 1/12 of mass of C16 atom, 1/12 of mass of C612 atom as the atomic mass unit. Right. In the next line, right? Atomic mass unit AMU equals 1/12 mass of C612 atom. Next bullet point. Relative atomic mass of an atom. Relative atomic mass of an atom can be calculated based on below equation. Based on below equation. Relative atomic mass equals, right on this equation. This one.
Harris.
Right. Okay. So let's do some examples on this one, right? Let's do some examples. Otherwise, we can't solidly understand this concept. So, write the first question, number 1. Mass of capital M atom. Mass of capital M atom is 6.64 into 10 to the power minus 26 kilograms, and mass of C612 atom is 1.99 into 10 to the power minus 26 kilograms. Find relative atomic mass of capital M. Find relative atomic mass of capital M. I will do this question for you, right? So we can say, we know the equation, atomic mass or relative atomic mass is equal to mass of capital M divided by 1/12 of mass of C612 atom. C612 atom. So we can say mass is 6.64 into 10 to the power minus 26 kilograms divided by 1/12 of mass of C612 atom, that is also given 1.99 into 10 to the power minus 26 kilograms. So you can do this calculation and get the answer accurately, right? So you have to take the final answer, otherwise this will not work. You have to take the final answer. Okay, so this can be rearranged as 12 into 6.64 into 10 to the power minus 26 divided by 1.99 into 10 to the power minus 26. Kilograms will be cancelled off, right? Minus 26 will be cancelled off. Then you have to do this one. Take the final answer. I will push you to take the final answer. Don't use the calculators. Do it by manually. You can use your manual method, or you can use your log tables. I recommend you to use the log tables. Get the final answer. Don't use the calculators, otherwise, because the calculators are not allowed for this in our scopes. Right? Can you tell me the answer for this one?
සර් ඒක සිම්ප්ලිෆයි කරද්දි මේ අවසානම තැනට කරන්න ඕනේනේ.
Yes, of course. This is what is needed in chemical calculations. From the first question beginning onwards, you have to take the final answer. If you check the past papers questions, for an example, MCQ question, if you take MCQ question is with the final answer, right? So that means you have to take the final answer. Sometimes, not sometimes, in essay type questions, you have to get the final answer, otherwise you will not get the full marks, right? For the calculation part, marks are not allocated mostly. Only few marks are allocated for the final answer. If there is no final answer, you will not awarded with the marks, not for the calculations. If this is the question, for an example, let's say if this is the question, marks will be allocated for this one, writing down the equation, if there is corresponding equation, and the substitution step, right? And for the final answer, not for the calculation steps. So if the final answer is not there, you will not awarded with the full marks, right? So writing down the equation is a must, substitution step is a must, then getting the final answer is also a must.
39.53 වගේ.
එහෙම බෑ. Final answer එක ගන්න ඕන. You have to take the final answer. So that means if you use the log table, you will get the answer with some fixed decimal places. That final answer is needed for this one. Okay, so I will leave it to you to get the final answer. Uh, Maybe this is around 39. I don't know. So like 6, yeah, around 39 maybe. Around 39 maybe, yeah. But it may be close to 40 because in the denominator there is 1.99, not 2. So you have to use the log tables, right? I hope you can remember the log table calculations, right? Matagal log table calculations, you remember? Because this lesson needs chemical calculations. Sorry, chemical calculations need the logarithmic calculations, definitely. Otherwise, you can't take the final answer. So if you use the log calculations for this one, this will be log 12 plus log 6.64 minus log 1.99. 1.99. So in this manner, you can take the final answer. After that, you have to take the antilog course, of course. As I can remember, this is more close to 40, not 39. Right, the next question, next one. Leave some space, take the final answer. I will check this one. Mass of capital A atom, mass of capital A atom is 14.123 times of 14.123 times of mass of C612 atom. Mass of C612 atom. Find relative atomic mass of capital A. Find relative atomic mass of capital A. Can you do this one and send it to me? You have to do the calculations. This is easy. I will do it later. No, it will not work. You have to do it right now. Okay. Otherwise, this will not work.
mass of C612 atom එක අපිට දීලා නැහැ. එතකොට ඒකත් හොයන්න ඕනද?
No, it is not needed. හිතලා බලන්න. Whether it is needed or not. Yes, good. Very good. So you can take it as A and A. Yeah. Okay. Good. So let's move on with this one. Yes. Now, let's say, for an example, there are what you call isotopes in some atoms, right? So chlorine has two atoms, two isotopes, Cl 1735, Cl 1737. But we know for the calculations, we take mass of chlorine atom as 35.5. This concept comes from the average relative atomic mass. Because if you have a sample of chlorine, this is having Cl 1735, and also this is having Cl 1737. We can't exactly say whether this is 35 or 37. So because of that, we have to take an average relative atomic mass. How to do it? You calculate the relative atomic mass of Cl 1735, and you calculate the relative atomic mass of Cl 1737, right? And get the average of it by using the relative abundance, something that we have discussed in the unit 1, the relative abundance. When we are discussing about the isotopes, I have calculated this one, I have done these calculations, right? So if I recall this concept, how to calculate the relative average relative atomic mass, we take relative atomic mass of Cl 1735 multiplied by relative abundance of Cl 1735, and add this one with relative atomic mass of Cl 1737 into relative abundance of Cl 1737. You have divided by relative abundance of Cl 1735 plus Cl 1737. So this is how you take that Cl 35.5, right? So if the relative abundances are negligible for some isotopes, for an example, hydrogen 1,1, hydrogen 1,2, and hydrogen 1,3, the relative abundances of H12 and H13 is uh, very slight, very minimum. So therefore, there will be no impact to the relative atomic mass of 1. So directly we are taking it as 1, right? It's an approximation, but it cannot be neglected for chlorine because these relative abundances are very considerable values. Cl 1735 is 75% around, Cl 1737 is 25% around, right? Approximation. So therefore, they cannot be neglected. That's why we take Cl as 35.5 as the relative atomic mass. Actually, that is not a relative atomic mass. That is a average relative atomic mass, right? In some books, this is called as mean relative atomic mass as well. So both are same in terms of the calculations, right? So you have to take it either a mass, so either a mean or an average, right? So this happens only when there are some isotopes. This concept we have discussed. This concept we have calculated as well. Only new thing here is we are using relative atomic masses for the calculations as the masses, right? Put a bullet point and write down. If there are isotopes, if there are isotopes of an atom, if there are isotopes of an atom, average relative atomic masses, average relative atomic masses, average relative atomic masses are used. Average relative atomic masses are used. Next bullet point, as an example, chlorine, chlorine is a mixture of, chlorine is a mixture of Cl1735 and Cl1737. Cl1735 and Cl1737. 35 and 37. Its apostrophe s, IT apostrophe s, its average relative atomic mass can be calculated as follows. Can be calculated as follows. Right, write down this equation. Let me know once you're done. No? Done? Oh, done.
Yes, sir.
Okay. Now, this is about the evaluation of the concept. Relative atomic mass is uh, evolved into average relative atomic mass when it comes to the considerable amount of isotopes are there, right? Now, the same concept can be used to measure the mass of the molecules as well, right? So this here we are talking about the atoms. Now, the same concept can be used to measure the mass of molecules as well, right? So relative molecular mass, it is called as the relative molecular mass. Very simple concept, but very powerful concepts. Relative molecular mass can be calculated mass of one molecule divided by 1/12 of mass of C612 atom. So in this manner as well, we can calculate the relative molecular mass. So this is called as RMM. Previous one is called as RAM. So relative molecular mass and relative atomic mass. Very simple concepts. What we do is we take the mass of one atom or molecule divided by 1/12 of C612 mass of a mass uh, of an C612 atom. 1/12 of mass of C612 atom. It's a very simple but very powerful concept, because only these concepts we could do the chemical calculations very easy. Otherwise, we have to take the mass of an atom in 10 to the power minus ranges. So it is quite complex, right? So that's why IUPAC, International Union of Pure and Applied Chemistry Union, has defined, okay, let's take the mass of 1/12 of C612 atom as the atomic mass unit. Then let's measure everything based on this relative one, right? So all the calculations that we do in chemical calculations are relative things, right? But since the whole universe is aligned to one relative unit, there is no problem. Otherwise, if like, for an example, length is measured inches uh, in uh, in UK, sometimes in USA as well, but we are measuring them in meters, right? Metric units. We are using SI units. So because of this because of this conflict, we always having some kind of problems, right? So for an example, like Chinese people are using lunar calendar. We are using Julius Caesar's calendar, right? Roman calendar. So now I have many Chinese friends, right? So when I going to wish them on their birthdays, they are saying, no, no, this is not my birthday. According to my according to the lunar calendar, this is my birthday. So they are following the lunar calendar, right? But when they come to Sri Lanka and do the visa registrations and everything, they use the Roman calendar birthday. So they have two birthdays, right? Roman calendar birthday and the lunar calendar birthday. So likewise, when you take different measurements, the world will be very confused. But this is a very fixed one. IUPAC has defined mass of 1/12 of C612 atom as the relative atomic mass unit. So it is applied for atoms and as well as the average relative atomic masses to when it comes to the atomic samples with the isotopes. Then we are using it for the molecules as well, right? Right. A subtopic: relative molecular mass. Relative molecular mass. Put a bullet point and write down. The same concept can be used the same concept can be used to measure the relative molecular mass of a molecule. To measure the relative molecular mass of a molecule. Next bullet point. 1/12 of mass of C612 atom. 1/12 of mass of C612 atom is used as the atomic mass unit. Atomic mass unit. Right. Now write down this equation, which is you can see in the black box. Right. Right. Example number 1. Example number 1. Average mass of carbon dioxide molecule. Average mass of carbon dioxide 1 molecule. Average mass of carbon dioxide 1 molecule is 3.667 times of 3.667 times of carbon 612 atom mass. Carbon 612 atom mass. Calculate relative molecular mass of carbon dioxide. Relative molecular mass of carbon dioxide. Right. So we can write the equation like this. Relative molecular mass. So mass of one molecule is 3.667 times of mass of C612 atom. So let's say mass of C612 atoms to be X. So this will be 3.667 times X. So this is 1/12 of X. So you can calculate this one as 12 into 3.667. From this way, you can take the answer, right? You have to take the final answer as well. Otherwise, these things will not work. You must take the final answer. Okay.
Okay, sir.
Right. So relative molecular mass can be calculated based on this equation. And also you can calculate based on relative atomic masses as well, right? How to calculate by using relative atomic masses is, I think you know this one from your levels, but refresh your memories. So for an example, let's say I want to calculate the relative molecular mass of H2O. Relative molecular mass. So how to calculate this one, relative molecular mass? You take relative atomic mass of hydrogen, RAM of hydrogen, multiplied by number of atoms, that is 2. And you take relative atomic mass of oxygen and multiplied by 1. We know relative atomic mass of hydrogen is 1, 1 into 2, plus relative atomic mass of oxygen is 16 into 1. So this is 16. In this manner as well, you can calculate the relative molecular mass. Simply, this is the summation of relative atomic masses of the atoms in the molecule. If I go further, H2SO4, relative molecular mass of H2SO4 is, you can say, relative atomic mass of hydrogen into 2 plus relative atomic mass of sulfur into 1 plus relative atomic mass of oxygen into 4. Hydrogen is 1, sulfur is 32. Don't worry, these things will be given to you in the examination as well. Or sometimes when you do the calculations, you can remember these things very easily. Oxygen is 16. So this is 2 plus 32 plus 64. So this is 98. So this is also another method to calculate the relative molecular masses by using relative atomic masses of the composite atoms of the molecule, right? Put a bullet point and write down. Relative molecular mass of a molecule. Relative molecular mass of a molecule is equal to the summation of relative atomic masses of atoms of the molecule. Relative atomic masses of the atoms of the molecule. Right? Example number 1. You can write down like this. Relative molecular mass of H2O. Here you can take RMM of H2O. You can write down this one like this. And you can write the second one as well. Relative molecular mass of H2SO4. Write down both of these two.
relative molecular mass mass of H2O 18 then.
Oh, so my calculation is wrong. That is 18. Yes, correct. That is 18. 16 into 1, 1 into 2, that is 18.
Yes, sir.
Right. Now, I will give you some examples. So here are some calculations. Number 3, Na2CO3.10H2O. You write down these things as a homework one by one, then you can do it at home. HNO3. So you have to find the relative molecular masses of these molecules. Right? I will give you relative atomic masses. Otherwise, still, maybe you can't remember some. Write this down.
Okay, sir.
Right. So let's complete this one at home. So we will meet tomorrow as well. So tomorrow, same time. Let's stop the class from here for today. Tomorrow we will be starting the Avogadro number because I need a fresh class to start the Avogadro number. So tomorrow we will start Avogadro number, same time. Okay. So we'll stop the class from here for today. Thank you. Good night, Buddha.
Yes, sir. Thank you,